Here is an explanation for the answer to final exam question number 67 in Electronics Demystified, 2nd edition. If you will refer to page 431, you will find the question. It talks about a Class A JFET amplifier. JFET, that's this thing. This particular thing happens to be an N-channel JFET. Remember what JFET stands for: Junction Field Effect Transistor. Exhibits a very high input impedance, and the output impedance depends upon the circuit configuration. This is a schematic diagram of a generic N-channel JFET amplifier circuit. It can operate in Class A with this kind of biasing, with only this resistor at the gate. In a bipolar transistor circuit, you would need to also provide a resistance between the base and the positive power supply voltage, but in the case of an N-channel JFET, you don't need to do that. If it were a P-channel device, this voltage here, of course, would be something on the order of minus 12 volts. But anyway, this is a generic amplifier circuit that can operate in Class A. Well, if we design a Class A circuit properly, what will happen when we get small changes in the gate voltage? That's the fluctuations in this input signal will cause the voltage on this gate to fluctuate, thereby changing the amount of current that flows like that. Well, in an ideal circuit, a small change in this voltage will produce a relatively larger change in that current. And in order to show graphically why that is true, we can bring in a graph of gate voltage and drain current. This particular graph shows drain current here as a function of gate voltage for a typical junction field effect transistor, and the Class A zone is in this straight line part of the characteristic curve. Now, if you will notice, suppose that we have a signal that causes the gate voltage to fluctuate between, say, here and here. You'll notice that the drain current fluctuates a lot when the gate voltage fluctuates just a little bit. The reason for that is that this curve in this zone has a steep slope, so small changes in this gate voltage back and forth this way produce relatively larger changes in the drain current. So the correct answer to this question, when all is said and done, is B. If we design a Class A JFET amplifier circuit properly, small changes in the instantaneous gate voltage, that's this, going along the horizontal axis, will produce relatively large fluctuations in the drain current. That's this, going along the vertical axis. So again, the answer to this question is B.